we're going to do the exercise exploring the mouse DPP6 gene. So the exercise says genetic variation in the dipeptidyl peptidase 6 gene, DPP6 in human, has been previously strongly associated with amyotrophic lateral sclerosis, ALS, a lethal disorder caused by progressive degeneration of motor neurons in the brain. So the first part says, search for the DPP6 gene in mouse. So I'm going to put DPP6 into this search box, and I can make sure it finds me mouse by selecting mouse from this drop down here. And now I'll hit go. Because I selected mouse, the mouse gene has come up as the first result. If I hadn't selected mouse, I could use this search facets here to narrow down to mouse because human would come up first. So I'll select the gene. This takes me to the gene tab. So the question says, click on the ENSMUST, and that's 6 zeros, and then 71500 transcript to open the transcript tab. So I'm going to click on this show transcript table, which will display the transcript tab. And here is the transcript that I'm looking for. And the question says, how many exons make up this transcript? This is shown here in the summary. This transcript has 26 exons. The next part of the question says, click on exons to display the exon sequences of the transcript. So I'm going to click on exons. I'll just hide this transcript table. And here we can see the sequence of all of the exons. And the question says, which exon contains the translation start? So the untranslated region, the UTR, is shown in this orange text. The translated sequence is shown in the blue text. So we have the switch from orange to blue here, and we have an ATG for our start codon shown here in exon 1. The next part says, what is the exon ID of the largest exon? So I'll look at the length, and I'm just going to scroll down this table. I know that I've got an exon here, which is 762 bases, but if I scroll down, I'm looking to see there is a larger exon here. There's one that's 856. So this is, and this is the last one, so I know that this is the largest one. And so the exon ID is this number here, this ENSMUSE for exon, and then we have 5 zeros, and then it's 773588. And the next question asks, what is the start and end phase of exon 2? So I'll scroll back up to exon 2. And the phases are shown in this column here. So the start phase is 0 and the end phase is 1. The next part says click on protein summary. So I'll go to the top of the page. I'll click protein summary. And the question says how many protein domains or features fall within the second exon. So the exon structure is indicated by these 2 shades of purple. So this is our first exon in light purple, and exon 2 is this in the dark purple. And I can see I've got this green box, which is, if I click on it, I can see it's transmembrane helices. And I've also got this low complexity domain here, which overlaps as well. It's also part of this large panther domain, which we can see here as well. It says, the next part says, what is the PFAM protein domain at the C terminus of the protein, and how many exons does it fall into? So if I go to the C terminus and PFAM, we have this peptidase S9 prolyl oligopeptidase catalase domain. I can also get the catalytic domain, I can get that if I click on the pop-up. And it says how many exons does it fall into, so we can count how many of these alternating shades of purple. So we've got 1, 2, 3, 4, 5, 6, 7. And which amino acids does it cover? This is here in the pop-up. We can see that it covers 582 to 787. The next part says click on domains and features. So this is just under protein summary in the menu. And the question says which domains are associated with PFAM? So if I look under PFAM, you can see you've got this PF 00930 domain, and we've also got this PF 00326 domain. And it says how many genes in the mouse genome have the IPR 002469 domain. So if I look over here, I can see that this IPR 002469 is this PFAM domain. And I'm going to click on this link, display all genes with this domain. And this gives me a karyotype showing me where all of the genes are with this domain. I also have a table of all the genes, and I can see that there are 6 of them. It says what chromosomes are they found on, which I can see clearly from the karyotype. I can find it on 1, 2, 3, 5. 5 is the one that we're currently looking at, because that's shown in red, 9 and 17.